Okay, so find the z-scores for 220. Here you go. What's the z-score for 200? How'd you find it? Here you go.
Oh, yeah. 200 minus 225 over 10.
Over 10. And you got?
Negative 2.5.
Great. Next one. Austin, what'd you get for your other z-score?
0.5.
How'd you find it?
225 minus 220.
220 minus 225 divided by, because it should be negative, right? It's below the mean, so it should be negative, and you got negative 0.5, you said? Yeah. Okay, good. All right, so then, everybody do a picture. Right, so make sure that you do your value minus the mean. That way, if it's below the mean, it's negative. If it's above the mean, it's positive. Then draw a picture and find your probability. So here's my picture. Draw a hill, line, little mark. Negative 2.5 and negative 0.5. They're both on the left. So make two little lines on the left, shape between them. And let's see, negative 2.5 is further negative than negative 0.5. So that's the lower one. And then we're going to do normal CDF of negative 2.5, comma negative 0.5. And everybody got what?
0.3023.
32?
Right.
I got 0.332.
It's
3. Yeah.
yeah, there you go.
Now, this is the number inside of here. 0.3023. It's that. So your area should go above or inside, right? And the z-scores of the x values should be below. Now, if you wanted to, you could put the x values in there also. In terms of x values, then I might have a second row of my x values and say, okay, here's my mean. My mean is 225. This first one is 220. This last one is 200. Right? But remember, the x values are a different row than your z-scores. They don't mix and match them. Don't go comparing 200 to a z-score of 0. Right? Compare 200 to a mean of 225. Are you talking about calories or z-scores? They're two different things. Everybody with me?
Yeah.
So these are calories. These are z-scores. Okay. Good. How about C? What does this mean in words? Does anybody have an answer to that? So what was it? It was 0.3023. What does that mean in terms of words? It means that if I eat a chocolate bar, I'll gain 0.3023 calories?
No.
No.
It means that 30.23% of the data is within negative 2.5 and negative 0.5 standard deviations.
Yeah. What she said. 30.2% of, well, and we're going to say of data. In this case, what's our data? Chocolate bars will, well, okay, so the z-scores will be between that, but that means that there will be between
220 and 225.
Yeah, 200 and
Or 220
220
calories.
Perfect. Make sense? So that means that 30.2% of all chocolate bars will have between, I should put, will have 200 to 220 calories. Okay, did anybody else do it? Something else using the word probability? Yeah.
I wrote it illustrates the probability that the calories of the 1.5 ounce bar will fall between 200 and 220 calories.
I just put chocolate bar so I have, we all know it's a 1.5 ounce. Chocolate bar will have, will what, you say?
The probability that the calories of the chocolate bar will fall between 200 and 220 calories.
Is 30.2%. Good. Okay, that works. Either one is fine. Somewhere along those lines, right? Either talking about the probability that they're between these two amounts, right? Those calories are between the two amounts, or the number of chocolate bars that will have calorie counts between those two. Great. Now, draw a picture. Find the probability X is less than. Remember, if you're not sure, draw your little fish, draw the little barracuda. He ate the X already. He's going for the 200. The 200 is bigger. All right. I was going to say Nemo, but Nemo doesn't really eat other fish, so it's kind of harder to make him convince. I don't know. All right, so 200. So here in my middle is 225. 200 is over here somewhere. And that has a z-score of, it says a z-score of 0, that has a z-score of negative 2.5. So personally, I find it easier to leave out the x values and just put the z-scores so that you'll get confused about the normal CDF situation. Do you know what I'm saying? So here, what's my z-score way out here? Negative infinity. Negative infinity. So we are going to do normal CDF. What comma what? Fill those blanks in. Fill them in and get your answer. Michaela, did you get your answer already? What did you do for your normal CF for the first one? For the first blank? Negative 100? Okay, that sounds good. I would put 600 just in case. And then what did you put for the second part? Negative 2.5. And 0062 or 26? 62. Great. Next. Everybody on board?
On board.
Awesome. Okay. So now we're finally done reviewing. Now we're going to get into our notes. We're going to finish up 6.2 and then take a break. So we need to move through this ideally in the next 10 minutes, maybe 15. So sometimes we want to find a z-score where we want to, where a certain percentage lies above or below. So for example, so in this case, we're given an area. We're trying to find the z-score that matches up with that area. So for example, the cutoff for the top 20%. So that would look like this. Here's my little thing. I'm not going to shade, but the top 20% would be this half over here, right? Top 20, and I put 20% in there. Do you see what I'm saying? So you have to shade, just write them in. So this is sort of the opposite, right? We, instead of giving them a z-score and finding an area, we're given an area, we're trying to find the z-score. So my question to you is, it sort of undoes it. So what are things that undo that we're familiar with? Like, how do you undo addition? Subtraction. So the inverse of addition is subtraction. What's the inverse of multiplication? Division. Great. The inverse of normal CDF is called inverse norm. It's the inverse of the normal CDF, inverse norm. So it kind of undoes them. So here, it's the opposite. We are giving them. We're going to feed it an area, and we're going to get a z-score. And why? Because a lot of times we want to know top 20%. What score do I need to get to be in the top 20%? All right. So how do you do it? Same idea. Second bars, go down to the third option, which is inverse norm, and you're going to feed it an area. Here's the thing. How will it know whether it's the area on the left or the area on the right? It doesn't know. So we're always going to feed the area on the left so that it always knows which side you're feeding it. Does that make sense? You got to pick one or the other. Yeah, that's what it takes. It takes the area on the left-hand side. Here's an example. Find the z-score for the bottom 25% of the population. So here is my thing here. This is the bottom 25%, so 2.5%, sorry, so it's in decimals, it's 0.025. Right, 2.5%, 0.025. So I have this area, I'm going to feed it into inverse norm, and I'm going to get negative 1.96. That's what you get. Everyone want to try that? Everyone bust out your calculators. Do it very quickly. So how do you do it? Turn on your calculator, clear it. Second bars, just like you do for normal CDF right here. Second bars. Down to inverse norm. Inverse norm. Enter. I'm going to put in 0.025. You got to put it as a decimal. Enter. I get negative 1.959996. So 1.95, negative 1.95 when you round it. Now, here's the thing. If I were to reverse this and do normal CDF of negative infinity, comma negative 1.96, I'll get back my area 0.025 because they're inverses of each other, right? Okay. All right, so let's do lab problem 4. I'll walk you through the first part. Draw your picture. I want 82.12% is on the left of it. So the left side is this side, 0.8212. Write it as a decimal. Is on the left of it. You're trying to find this number right here. For the second one, if you get that far, 10% is greater than or equal to it. Actually, let's not worry about that. Let's just do the first part right now. So everyone draw a picture. Find that z-score. Find that z-score. Find that z-score. It's the inverse, right? You feed in an area, a probability, it gives you a z-score. Curve is your hill, and then left. Well, it's all under. Everything's under. It's underneath the curve. Yeah, under the curve means yeah. So the left is this side. Under the curve means under the.
Okay, that was
literally underneath.
91.9.
So again, z-scores you should round to 2 decimal places. So has everybody had a chance to do this yet?
Yeah.
I'll walk you through it. 8212. You haven't done it. Do it now. Second. Second, bars, down to inverse norm. What's the area on the left? 0.8212. You cannot put 82, it'll give you an error because you have 820%. 0.91994. So that, when you round it off, is 0.92, yes? Now this next one, only 10% is greater than or equal to it. So this part here is 10%. But the thing is that I need to feed it the area on the left. trying to find here, what's the area on the left side of this?
0.9.
Yeah, 90%? Does everyone understand? 10% on this side means 90% on the other side. So the whole area has to equal what? 1 or 100%. So 10% on this side means 90% on that side. Write it as a decimal. So this is 90%, right, which is 0.9 or 0.90 if you want. Find the z-score.
Couldn't you just do the putting your calculator as 0.1 and then do it to the right?
Yeah, if you have a fancy calculator.
Oh, it's not everything.
Right, so if you have a fancy calculator, then it gives you the option of left, right, center. So then you could just put right if you wanted to, that's fine. But 85% of you will just have the basic calculator, which you feed it the left area. What do you got? Yes. Veronica, help me out here. Okay, so let's take a look. So everybody should have done inverse norm of 0.9 or 0.90, and you got 1.28. That's the z-score that goes right here. If anybody didn't put in 0.1, inverse norm of 0.1, you'll get negative 1.28. Why? Because it's symmetric, right? 10%, the lowest, that'll give you the lowest 10%, which is symmetrical with this side, the highest 10%. So you get the negative 1.28, positive 1.28, right? They're symmetric to each other. So you could, in theory, you could, if you know your signs of negative, positive, you could, in theory, put that up and then put in, 0.10, but then remember to switch the signs. Okay. Here's another one. I think this might be in your homework. I'm not sure. But I want this green area here. I don't know what the green area is. I need to find it so I can do inverse norm. So I want this fella there. I only get him if I can find that area. So can I find that area? Can I find this area here?
Yes.
Yeah.
Yes. Because I know that this area plus the 0.4175 should equal what? 50%. Exactly. Because everything from here over should be 50%. So if I subtract those, find out what you get, and then find that z-score. I'll give you folks a minute to do that. Look. Let's see what we have. So we found this area here. It is 0.0825, right? Because 0.5 minus 0.4175 equals 0.0825. Now, you need to figure out what that z-score is. So the z-score is going to be inverse norm, right? Because inverse norm is the opposite. Normal CDF, you give the z-scores You feed it z-scores, it gives you an area. This is the opposite. You feed it an area, it gives you the z-score. So the area I'm going to feed it is going to be 0.0825, and you will get negative 1.39. So the z-score here is negative 1.39. Great. Now, everyone feeling okay with this? Yes, question.
So if you were trying to find the z value and like you have like a given area, but what if it's like past the zero and you don't know how much?
Oh, yeah, then you can't solve it.
Oh, okay.
Yeah. You can only solve it pretty much, you can only solve it if you have the ends. Because you can find the other half from the ends.
So we don't have like a problem like that?
You will, yeah, that's impossible, you can't solve it.
Oh.
Yeah. Now, if it's perfectly symmetrical, like even amount on the left and the right, then you could say, oh, well, half of it's over here. You know what I'm saying?
Yeah.
Like you could solve that if they said something like, if the question was something like this, was, this is perfectly symmetrical, and this is 60%. You know what I mean? Then you know the rest of it must be 40%, 20% here, and 20% there. You know what I mean? You could do it that way. But that's unless it's perfectly centered around the zero, you can't solve it otherwise.
Yeah.
Okay. Now we're just going to add one little twist to it. We're going to apply. We're going to use it with applications. So all that means is, after you find your z-score, one more step. That's it. Just one more step. Convert your x value to a z-score. Which makes more sense, because if someone said, well, what do I need to score to be in the top 10%? And you just say, well, buddy, you need to have a z-score that's 1.28 or higher. They're going to look at you like, what the heck are you talking about, right? You say, you need to have a score of 1430 or higher. You need to give them a number. Do you understand what I'm saying?
Yeah.
So how do you find the x value that goes with that z-score? Well, what's the z-score again? It's the number of standard deviations you are above or below the mean. So you start with the mean, mu, and you add that many z standard deviations to it. All right, z times whatever standard deviation is, you add that to it. So you take your mean, you add z number many standard deviations. That tells you your x value. You can also look at it as, it also comes also from the z-score equation, right? Z equals x minus mu over sigma. How do I solve that? Multiply both sides by sigma. I'll do it on the back side, it's easier. Oops. So then I have z sigma equals x minus mu. And then you just add mu to both sides. And then you have z sigma plus mu equals x, which is the same thing as mu plus z sigma. Either way, right? It's those two things added together. All right. So let's take a look. So this is the bottom of your page. Fill these in. Thank the 2 o'clock class for finding this easier and faster. All right, so you should have those filled in. If not, take a picture of it. I'll give you 5 more seconds. 5, 4, 3, 2, 1, 0. Also, the next page, the very bottom of the next page, you think this is one, right? Drawing a normal curve. You do not need to shade the area. Let me rephrase that. You don't need to shade the area. Right in area for the probability, proportion of percentile, Find the area left of the data value 1. This is just saying the same thing in different words. But the last part, I think this is what the top of your notes says. Oh, in words. Oh, right. Oh. Well, that's the previous slide. What the heck? There it is. My bad. In words, x equals the mean plus z times the standard deviation. Okay. Everybody have it? Great. Pictorially, given the area on the right side, find the, oh, right, so the area on the right side, first you have to find the area on the left side. And then use inverse norm to find your z-score, and then use that formula to find your x value. So that's just it as in the picture. All right, so here's an example. So that's the next thing down the list. This is my example you're going to do with me. Top 10%, which is different than yours. Yours is top 20%. Has a mean of 200, standard deviation of 20. Standard deviation of 20. All right, find the mean low scores to qualify. All right, so I'm going to draw my picture. Top 10%, that means that this is 10%, which means that the other side is 90%, 0.9. Everybody all right with that part? I'm going to do inverse norm of 0.9. Inverse norm of 0.9, and I will get 1.28. So this is 1.28 there. So then the last thing I need to do is I need to find the x value that goes with this. So my x value is equal to my mean plus my z-score times my sigma. So my mean is 200. My z-score is 1.28. That's what I just found. And my standard deviation was 20. If I do that, I'll get 200 plus 1280 twice. 2560. 225.60. So that means we need to score 226 points to get into the police academy. Okay? Let's see what you folks have. Hold on.
It's the same one.
Oh yeah, so your lab problem's the same. Oh, right. So yours is almost the same. The only difference is it's top 20%, not 10%.
Yeah, both.
Right. Well, this is mine, the example, which you're supposed to have filled in, as I did it, and then do yours on the bottom. When you're done with that, take a break until 37 after. At 37 after, I will do the magic trick. Magic trick.